the BFS and AFS of this graph is going to be this. So we know this mentally, right? So we know this mentally. But how does the machine know that, first you need to go to 0, 1, 2, and 3. And we are going to do what? We're going to write the function of BFS. Right? Now, what is the function of BFS? You see here, I'm creating a function, BFS. And what am I doing? Right? I'm writing the function name and I'm expecting a value function. You see here, in line 36, I'm writing BFS and DFS. And what am I saying? BFS of 0. That means I am starting at 0. I'm starting at 0. Right? That means I'm starting at 0. Now, what I am going to do is I am going to create two lists. One is visited and one is a queue. Since this is a queue data structure, right? I create a queue and I'm going to say what? I'm going to say visited. Visited is an empty list. Queue. Queue at the moment, since I'm starting at 0, it becomes 0. Right? In the queue, now we have 0. Now, let us start the code here. Now, what does the code say? While queue. While queue. What is while queue? I'm saying run the code until while becomes empty. Is it empty now? No, it is not empty. We have 0. So, we're going to run this loop. Right? What does this line say? I'm going to pop the first element. I'm going to pop the first element. Right? When I pop the first element, what does node become? Node becomes 0. Right? Since I'm popping 0, now the node becomes 0. Now you're going to check whether this node value 0 is in visited or not. Is 0 in visited? At the moment, visited is empty. Since it is not in visited, we are going to add the 0 to the visited. Now after this, in the first while loop, now it becomes like this. We are going to add the visited. Now you are going to check for one more condition for neighbor in the graph of node. What is this line of code? For neighbor in the graph of node. What is graph of node? What is graph of node? You see here, we have created a graph, right? We have created a graph. Graph of a node 0, graph of a node 1, graph of a node 2, graph of a node 3. And what are the neighbors of 0? And the neighbors of 0 are 1 and 2. Right? So I'm talking about these two. Right. Now we're going to check for neighbors of graph of 0. Graph of 0 means what? The neighbors of graph of 0 is 1 and 2. Now you're going to check, since it is the for loop, right? You're going to run 2 times. You're going to run 2 times of this neighbors, and first time, what is the neighbor becomes? Neighbor become 1. If 1, you're going to check whether that is in the visited. I think so. There is a cutoff here. So let me write it down. Okay. We're going to check whether the neighbor 1 is in the visited list and also neighbor not in queue. So we're going to check that whatever neighbor we have, it is not in visited, right? And not in queue. If that is the case, I'm going to append it in the queue. Now I'm going to update the queue. Now the queue will become 1. Right? Now you come back to the condition, right? You come back to the condition. Before coming back to the condition, you need to check for 2 also, right? Now 1 is done, right? Now go for 2. You check whether queue is in visited. No. Is the 2 in the queue? No. So what you're going to do, you're going to append the 2 in the queue, right? Now queue becomes 1 and 2. The queue consists of 1 and 2. So, right? It has not become empty. So we're going to run it. Now you're going to initiate the node value queue.pop. Pop of 0 means what? You're popping the 1. Now this time node becomes 1. Now if node in visited, you're going to check whether 1 is in the visited or not. Since 1 is not in the visited, you're going to append the 1. Now this time what becomes? This time the visited will become 0 and 1. Right? This part of line is done. Now for neighbor in the graph of node of 1. Now you're going to check the neighbors of 0, neighbors of 1 right? Now, what are the neighbors of 1? The neighbors of 1 is 0 and 3. Right? The neighbors of 1 is 0 and 3. I'm writing in the left side. You see here 0 and 3. What happens? We are going to run the for loop for the neighbors in a graph of 1. Right? First, you're going to run the for loop for 0. Next, you're going to run the for loop for 3. Now, you're going to check whether the neighbor is not in the visited and not in the queue. Then only you're going to append it in the queue, or else you're simply going to leave it. Now, you check for 0. You check for the first value 0. Is 0 in visited? Yes. 0 is in visited. You're going to skip the for loop because it exists in visited. Now, you check for the next one 3. Right? We check for the next one 3. Is 3 in visited? Is 3 in visited? No, it is not in visited. Is 3 in queue? No, it is not in queue. So what you're going to do? You're going to append the 3 into the queue. Right? Now the queue becomes what? Now the queue becomes 2 and 3. Because you have popped 1. Because you have popped 1 out. So here it was 2. Now since 3 is not in the visited, nor it is in the queue. So we're going to add 3 here. Right? Now come back to the loop again. Right? And you check the queue. Is queue empty? No. Queue has 2 and 3. Right? So we're going to run back the while loop. Let me erase this. 2 and 3 this time. Right? Now since it is not empty, we are going to run it. And we are going to pop up the first element, just 2. Right? And this time it becomes 2. Right? Now if node 2, you're going to check whether 2 is in the visited or not. Now this time in the visited, what we have? Visited has a 0 and 1. Right? Is 2 in 0? No. So this time you are going to update the visited and you're going to add the 2 here. Now this time the visited becomes 0, 1 and 2. Okay. Now you're going to check the neighbors of 2. What are the neighbors of 2? What are the neighbors of 2? The neighbors of 2 are 0 and 3. Okay. The neighbors of 2 are 0 and 3. Right. Now you're going to check 2 times. The for loop runs for 2 times here. Now if neighbor in visited, you're going to check for the first value 0. Is 0 in visited? Yes. 0 is in visited. So we're going to skip it. Now we're going to check whether 3 is in the visited and is it in the queue. Since it is not in the visited and not in the queue, you're going to skip it. You're going to skip it. Okay. Now you're going to check the while loop again. Now the last value you're going to have is 3. Right. Let us continue for 3. Now what we have in the visited? In the visited we have 0, 1 and 2. The last one in the queue is 3. Okay. Since the queue is still not empty, what you're going to do? You're going to take the node value as queue.pop. This time you're popping on this one value. Now this time the queue becomes empty. So until unless we append the queue here, right? So we know that this is the last while loop. Now, if node not in visited, is 3 in visited? No, it is not in visited. So you're going to append the 3 in the visited, right? You're going to append it. You have appended 3. Now the queue is empty. Now you're going to check the neighbors of 3. Now what are the neighbors of 3? The neighbors of 3 are 1 and 2. So let me write this down. The neighbors of 3 are, now you are going to run it 2 times because you have 2 neighbors. What happens in the first time? You're going to check for 1. You're going to check for 1. Okay. You're going to check for 1 and you're going to check it whether it is in the visited and queue. Is 1 in the visited? Yes. 1 in the visited. So you're going to skip it. You're going to skip it. Now next time you're going to check the second neighbor 2. Is 2 in visited? Yes. So you're going to skip it. So since you're skipping it, you're not running this part of code. Right? Since you're not running this part of code, you're not updating the queue. Now this time when it comes back to the while condition, since the queue is empty, we run the next line of code saying BFS visited. And what am I printing? I'm printing the visited. I'm printing the visited list. Now we are going to check it. We are going to check it with what we have written here. right? 0, 0, 1, 1, 2, 2, and 3. Okay. So it is matching with our expected output and the actual output. So this function runs well. This is about BFS. Now let's talk about DFS.